that a telco could mix and match and choose and evaluate very, very fast, very, very efficiently, right? But the switch doesn't have to just do switching. There are a bunch of functions that are really interesting to think about putting at that point in the network, right? What about load balancing? So I could imagine an F5 load balancer snap, right? Or HA proxy or Nginx if you come from a sort of cloud type world. Those things, again, just become apps that you can drop on. The vendors for those apps will update them when they want to update them, and those updates can be applied completely independent of updates to the OS, or intrusion detection, or firewalls, or software-defined networks. Suddenly, this becomes a place of innovation, and that innovation isn't all associated with the hardware manufacturer. It's not associated with the operating system. You're not dependent on us for it, right? It's essentially an open ecosystem of different players who are decoupled from each other and can specialize and do brilliantly, right? This is how we accelerate innovation. So to kind of make that real, right, let's have a look at a switch.
So currently we have the switch set up. We have the Facebook wedge. It's already been imported into our Metal as a Service. So for us to actually get the network operating system installed on it, we'll go ahead and commission it. Sorry, can you just give us a tour of Snappy? Just like a snappy command line. I actually have to still install that still.
Okay.
This is fun.
Okay, so hold it. Can you come back to that? Thanks. So we get these semantics. We get transactional update and rollback because those are blobs, right? We can get version B of the blob. We can go back to version A of the blob, right? We get some special semantics there. We also get an interesting security story because each of those apps is now compartmentalized. They can't touch each other, right? And from an update point of view, we can fix the biggest problem in security, which is the pace at which we can fix things, right? I can't guarantee you that Ubuntu is secure today, but I can guarantee you that we can fix it really quickly if we find an issue, right? And that's the real approach to security, architecture and change management effectively. And so this is great for switches, but think about it, it's also great for drones. This is what gets me super excited, right? Is that we focus on an enabling thing, not specific to telco, not specific to OCP, not specific to networking, drones, right? Imagine a drone running a well-known operating system, and you can get apps for that drone that can do innovative things with that drone. We make that drone kind of magical, right? Robotics. The vast majority of the open source robotic stuff happening on Ubuntu now coming to this mechanism. Self-driving cars. Almost all of them that we know of, running Ubuntu. Dell's IoT gateway, right? Using this mechanism. Essentially, anybody getting into that device now can create an app store effectively and shift the balance of innovation to software. Okay. So I want to sort of go from there and let's just look at operations a little. So we talked about innovation and unlocking innovation in the device at the top of the rack. But it is also interesting to say, okay, what can that top of rack do for me now, right? Imagine I've got a rack and it's up and running, and I now want to onboard another rack and another rack and another rack, right? What are all the things I need to do? Well, I've got hardware inventory, I've got OS provisioning, I've got PXE, IPMI, DHCP, all of those things I've got to get done. And that can actually be quite a process. You get a new OCP rack. OCP made that easy, right? You could get a rack at a time. But now you've still got to get through that sort of data center operations process. Well, the way we would do that is we use something called Metal as a Service, right, which is like a physical cloud, which will do all of those things. The way it works is it has a data center-wide controller off to the side. That's an HA, a couple of machines doing that, database, REST APIs, and so on. And then in each rack, there's a rack controller, which can also provide backup services to the racks left and right of it. Right? But that takes an extra machine in every rack, right? So what if we could essentially say, well, that's just an app. What if we could put that on the top of rack? And so that's what we kind of want to show you here. It's a never been seen before function. MAS is here. It can turn on racks. We'll show you that. This orange box over here is essentially a half a rack. It's 11 Intel NUCs in a box. So it pretends to be sort of half a rack for demo purposes. We're going to start by essentially using MAS to install the OS on a switch. So now you imagine we've gotten the second rack. What's the first thing we need to do? Put our OS on the switch, put our chosen network control function and other functions on the switch. And then we can also essentially use that switch to drive the onboarding of that rack. Do you want to just take us through that?
So we have our Facebook wedge, and it's ready to go. So there we go. All right. Easier to see the screen right here. So we will go ahead and commission the Facebook wedge.
So there's no operating system on this Facebook wedge right now.
Yep. And now it's getting powered up. And going through its basic post right now.
It's been detected remotely effectively. So now it will be turned on.
Actually, let's take this one.
Okay. I wondered if we had the demo effect going on.
Takes 2 minutes.
Oh, okay. So let's kind of let it do its thing effectively. Okay. So essentially, we're doing an automated onboarding of the new rack, starting with the switch, putting an OS there, putting your chosen network control plane there, putting the data center operational software there. That's the open source NAS rack control effectively. Then we can drive through the rack. Should we come back to the day? I kind of want to get through it. And so we can drive through essentially the data center, now starting to use the switch as part of the management fabric of the entire data center, right? Which gives us that extra 5–10% efficiency out of your 42U or your 50U rack infrastructure. Okay. So I see a picture. Is there a picture? I need to refresh the deck. Can you hit reload? So I want to ask during the hackathon, the Open Switch guys made a snap of their stuff. And it turns out the judges came in and that project won the hackathon competition. So I want to just give those guys 2 minutes to talk about their experience and a round of applause. Do you guys want to come up? Sorry, this is unexpected, isn't it? Just tell folks your experience, how you think, what you think this does for you.
Okay, so it's very unexpected. Okay, so what we think about storage is actually separate platform. So actually, snappy and still system separate platform, so we can start building applications in such a way we can start developing, and we can isolate from the rest of the applications that it has the feature that still can.
Things enough. Like,
Okay.
you did a great job. So your obviously still have data,
Yeah.
and so you also stuff like figuring the open stuff, and I have to do snap class, which I worked on this switch snap and ARM side. So like, it was really a team effort, and my credit is not here, but it's also my favorite one.
So a round of applause for those guys. So this is what I'm kind of excited about. This is the IoT corridor on our standard MWC. And every one of those sections over there is a different startup doing essentially software-defined innovation on some sort of thing. Some of those things are networking equipment. Some of those things are robots, drones, cameras, home automation things. But it's unlocking that ecosystem that is super exciting to me. Okay, so I think we've talked through the operation story. Last piece. Okay, so I think you can see how the traditional bulk compute, cloud, big data, data center story plays out. But there's another group here. This box over here is a DSLAM. Like I said, that is the box that concentrates, I think about 48 home routers effectively would go into that box. And one of those groups at MWC was a company called KeyMile. That are the first company to open source the designs for a DSLAM. So if you're in telco, you'll know what a DSLAM is. If you're not, it's an expensive box that a telco needs to buy to give you a home router. Anyway, I just want to give them an opportunity very briefly to talk about their thoughts on how that changes the sort of dynamics around that segment of the telco market.
Hi everyone, I'm Luca from KeyMile. I'm one of the guys behind this DSLAM box. So we really, as Mark pointed out, wanted to disrupt the access network in our market. And this is a Linux box from the day one. We took the advantages put forward by Snappy Ubuntu Core, and I can confirm that these advantages are there. We really experienced hands-on, so we are very familiar with the lower layer part of something to Linux. But these are details. The important part is this ecosystem allows you, one, to have near real-time provisioning end-to-end. So if I take this picture, from the wire communication to wireless, access to the whole cloud, you can really have near real-time provisioning. That's one here. The other one is having such an open ecosystem allows you, developers worldwide, to do applications for you. And already in MWC, we experienced, so we concentrated in our core know-how, the access part, and we created Snappies for that. But at the same time, we had a couple of guys beside us that were doing blockchains. They required computational resources. We had some resources not used. We just took their Snappy on our box, off you go. And this allows telco operators all of a sudden to monetize their infrastructure. The very same infrastructure that today costs money and is put under heavy cost pressure.
Luca, thank you very much. So I think we'll wrap there. Hopefully this has been a taste of how the decoupling of not just hardware and software, but hardware, the software tightly coupled to the hardware, the kernel, the operating system, and then the various control planes, enabling those each to come from the place where they can most credibly come, is a very powerful new mechanism. If there's time for any questions, I'd be super happy to take a question. Otherwise, thank you very much. I hope that was interesting. And all of these guys are doing amazing stuff. We don't profess to know anything about networking, but we know a lot about developers and ecosystems and enablement.
So what's, just a quick question. You looks like you're trying to show the demo, or?
I was just doing it in the background.
Okay.
Okay, so oops. Essentially the Snappy OS is now on the device, and Luke is essentially from a command line. I showed you a brief screenshot of what that looks like through the web, but from a command line, installing or removing or updating snaps, showing that sort of transactionality effectively from device to device. Questions?
Can you differentiate Snappy from containers or namespaces?
Sure. So a snap, when we load a snap effectively, we use some of the same kernel mechanisms that you would use for example, XD, which is a hypervisor from the container world, or Docker, which is essentially an application process containment thing. These are all using the same kernel mechanisms for isolation and sort of sharing or isolating different pieces. With Snappy, we have a slightly different goal to some of the other container systems. We actually want to share some things and not share other things. If you think about it, a snap wants to see the common services that the core OS provides, but it doesn't want to see other services from other snaps unless there's an explicit agreement between those two snaps to enable that. So we use the same underlying mechanisms, MAC-based security, namespaces of various types to set up the environment, essentially, the C group, essentially, that the snap operates in. There is, for example, there's a Docker snap, so you can just say snap install Docker, and then you can Docker run. And there's an XD snap, so you can snap install with XD, and then those give you those other kinds of containers. So if you wanted to slap Docker stuff onto a snappy device, that's easy enough to do. Other questions?
Looks like the demo is just about done.
There we go. So I think access is the next frontier. EdgeCore, for example, announced this week a series of access devices, Wi-Fi and physical, that will use this mechanism. And you see the DSLAM story. So this is essentially the OCP idea spreading to the edge of the network. And I think the further out it goes, the more innovation we will unlock. Any other questions? Thank you very much.
Thank you. So we can get some folks where the next session is Linux is awesome. Which I think anyone would doubt, but particular networking focus to it. Thanks a bunch, Mark, Luke.
朝の9時からも同じなんだ。そうですね。アクセスポイント。アクションのカードにあれが乗ると、その後で、じゃあキャプティブポータルとかなんか、今だからそういうの機能を入れられる。
Yeah.
Oh, you know what? I just powered it off.
Yeah, so we're continuing on the software theme. So from the morning, a lot of folks in the room too. The morning we covered Sonic contribution from Microsoft as a possible software stack on top of OCP switches. And then we covered OpenSwitch as another stack. And now we're going to hear, we looked at Canonical as a way to manage the provisioning of nodes onto the switches. So now we're going to hear from the folks, good folks from Cumulus, about how much networking you can do with Linux, just pure Linux, on top of an OCP switch.
Thank you. Go ahead.